What if the toughest wheels weren't made for Earth? That's the reality Michelin is stepping into with its revolutionary new moon-spec wheels, designed not for highways but for the harsh terrain of the moon. These wheels aren't just futuristic, they are a leap into a new era of mobility, engineered for extremes no earthbound vehicle could survive. At first glance, Michelin's Lunar wheel looks like a tire, but technically, it's not. There's no air inside. Instead, it's a completely solid structure made from a flexible thermoplastic material, a necessity when dealing with the lunar environment, where traditional rubber tires would fail instantly. Why? Because temperatures on the moon range from -400 degrees Fahrenheit to over 212 degrees Fahrenheit, not to mention intense solar and cosmic radiation. Rubber turns brittle in such cold, making it useless. Michelin, with its 130 years of tire expertise, needed something stronger. The answer: thermoplastic spokes that flex and absorb shock while maintaining structural integrity. These wheels are being designed for the upcoming NASA Lunar Terrain Vehicle (LTV) missions. Unlike Earth-based rovers, these lunar vehicles won't be hauling spare wheels. So, Michelin's wheels have to last the full mission, up to a decade, on the moon's unforgiving surface. That includes traveling through fine, loose soil, climbing 20-degree crater slopes, and resisting constant abrasion. Even if a few spokes break, the wheel keeps functioning, a key advantage over traditional tires that can go flat with one puncture. It's a rugged solution for a place where failure isn't an option. NASA chose 3 finalists to develop its next-gen lunar rover, Lunar Outpost, Venturi Astrolab, and Intuitive Machines. The latter, based in Houston, partnered with Michelin, AVL, Boeing, and Northrop Grumman for its rover project. NASA has already invested $30 million into their development, and Michelin's wheel tech is central to the design. Cyril Roger, Michelin's Director of Scientific and Innovation Communication, says the wheels are being tested under intense lab conditions that simulate the moon's temperature and radiation. The goal is simple: make a wheel that can go anywhere, no matter how hostile the environment. The moon's gravity is just 1/6 of Earth's. That means the rover and its wheels must be ultralight yet provide maximum traction and surface contact to avoid getting stuck in soft soil. Michelin's thermoplastic wheels are soft, flexible, and designed to lose as little energy as possible while rolling over unpredictable terrain. The tread design, the size of the contact patch, and the ability to climb out of sandy craters, all of it matters when you're designing for one of the toughest places in the solar system. You might ask, why spend millions on wheels that won't even be used on Earth? According to Michelin, the lessons learned from space tech can inspire innovations in everyday automotive applications. Whether it's tougher materials, puncture-proof wheel concepts, or better off-road performance, what survives on the moon can thrive in extreme environments on Earth too. As Roger puts it, a tire is a composite, an assembly of materials that don't naturally go together. The moon wheels challenge Michelin to rethink that entire assembly and push the boundaries of what's possible. This isn't just a cool side project, it's a technological experiment with potential global impact. The moon becomes a rolling lab for Michelin, helping the brand test materials and structures under the harshest imaginable conditions. At its core, this moon wheel project is about more than just space travel. It's about expanding human mobility, whether that's across Martian dunes in the future or across desert trails on Earth today. Michelin is using the moon as a proving ground to build the most durable, efficient, and smart wheels the world has ever seen. And for Lux Auto X followers, this kind of innovation is exactly the type of engineering that will influence the next generation of luxury, performance, and off-road vehicles right here on Earth.